So yield. We mean yield as the way farmers talk about yield. We talk to a farmer about yield, they're going to talk about how many bushels per acre they get. That's their crop yield, what it makes. So yield, a bushel is like this, and a peck's about that big. Yeah. A peck's not that big. Yeah. Okay, so we're talking about yield in terms of chemical reactions. Okay, so, and we're going to talk about three types of product, not three ways of looking at the product. So three kinds of yield. Type number one is called the actual yield. And they call it the actual yield because yield is what it makes and it's how much it actually makes. So you do the experiment and weigh the product. So you mix the chemicals and weigh the product. How heavy was your product? How many liters was your product? That's the actual yield. Then there's the theoretical yield. Theoretical yield is what the balanced equation says you're supposed to make. So every time I've asked you how much product would you make up to this point, every one of those answers has been a theoretical yield. Okay? Theoretical, in theory. If everything goes perfectly, I will get this much. If everything goes perfectly, I'll get this much. Okay? Those two sometimes disagree with each other. Sometimes you don't actually make as much as you, in theory, should make. So then you report the percent yield. And the percent yield is the actual yield divided by the theoretical yield times 100%. It's like every time you've ever gotten a test back, you've done a percent yield. You take how much you actually got on the test, divided by how much you could have gotten if everything went perfectly, times 100. So it's not new math. You do it every time I hand you back a test. Right? So actual. Now, one of these, they're going to have to tell you. Nah, they don't have to tell you theoretical. You can figure out theoretical. Actual, they have to tell it to you unless they make you go do a lab, right? So read the question carefully. They usually have to give you the actual. They could give you the percent, because if you got the percent, you figure out the theoretical and you can get the actual. So they have to give you one of these two, either the percent yield or the actual yield, unless they send you to the lab and ask you to weigh things. You know? So on a textbook assignment, they're going to have to talk about yield someplace in there. And you just have to figure out whether they're talking about what they measured or what the balanced equation. Well, normally they don't have to tell you what the balanced equation says you're going to make. So 6.8 grams of copper are produced when 3.92 grams of aluminate are reacted with excess copper 2 sulfate. What is the percent yield? Oh, and I'll be nice. I'll write the balanced equation. But it shouldn't be too bad. Aluminum and copper 2 sulfate, single replacement. Aluminum replaces copper, ends up next to sulfate. Copper's by itself. Do the crisscross with aluminum sulfate. Al2SO4 3, and then that means you need 2 Als and 3 SO4s. which means you need 3 CUs on this side. What is the actual yield? Everybody ready to do some math here? You're wrong. We have to do a lab, or look at what they told me about. They told me about copper. Copper's a product. It says is produced. It's a product. They're telling you about the yield. Okay. So what is the actual yield? The actual amount of product I made was 7.8 grams of copper. They had to tell it to me in the problem. I copied this number right there. Okay, because it told me how much copper is produced. Okay, what's the theoretical yield? I don't know, but I can figure it out. How much copper should I make? Well, I should stop making copper when I run out of aluminum. They told me about aluminum, and they told me copper 2 was excess. So I know what my limiting reagent is. So I start with the 3.92 grams of aluminum and turn grams of aluminum into moles of aluminum. And 1 mole is 26.98 grams for aluminum. Change the moles of aluminum into moles of product, and I want to make the same product as I had the actual yield. So I'm going to change it to moles of copper. And in my balanced equation, there's a 2 in front of Al and a 3 in front of copper. And then turn moles of copper into grams of copper. 1 mole is 63.55 grams. .92 divided by 26.98 times 3 divided by 2 times 63.55 equals 13.9 grams of copper. 3.92 had 3 sig figs. So any new math there? Now, we've been doing this for a week now, right? So but when we're figuring out product, we should make 13.9 grams if everything goes perfectly. Did everything go perfectly? No. So what's the percent yield? Percent equals actual over theoretical times 100%. We said the actual was 6.78 grams. The theoretical was 13.9 grams times 100%. So 6.78 divided by 13.9 times 100 is 48.8%. 3 sig figs. My 6.78 and my 13.9. So things didn't go well, right? Why didn't they go well? Well, we don't know. Something went wrong. Okay? And sometimes it's not your fault. Some reactions don't go all the way to completion. Depends on what you're doing. So it really is. There are some reactions where there's only 30% yield no matter what you do. Okay? And to get to get a master's degree in chemistry, the difference between a bachelor's and a master's, bachelor's you have to be the expert on material people have already done. Masters, you have to create new science. You have to come up with something nobody else has done before. That's what a master's degree means. Okay, so a master's degree. There's a lot of ways. One of the ways that people get master's degrees is by taking a reaction that has a low percent yield, trying to figure out why it has a low percent yield, and then making that percent yield, do it in a different way to make the percent yield go up. So you try to figure out why am I only get 30% here? What can I do to change that? Okay, because and then there's some reactions that just, I mean, think about it. If you burn something, can you control whether it makes carbon dioxide, carbon monoxide, or carbon? Not directly, can you? So you're really going to get a mixture of those, especially when you first light it. Does that make sense? So even in something as simple as burning isn't 100% efficient, so you won't get 100% yield because you won't make all the CO2 you're supposed to, because you'll make some C and some CO instead. No, I don't. I have a master's in educational technology. Because it's hard to get a master's degree in chemistry while you're teaching, because you got to spend 4 hours a day every day in the lab. It's kind of tough while you're teaching full time. Okay, so if you had started with 9.73 grams of aluminum, how much copper would you expect? Now this is a little bit different. Okay, 9.73 grams of aluminum. How much copper would you expect? Well, I can take grams of aluminum to moles of aluminum. 1 mole is 26.98 grams. This is the same math I just did a second ago with a different amount. So 2 moles of aluminum, 3 moles of copper. And then moles of copper to grams of copper. 1 mole is 63.55 grams. And I got that it is 34.4 grams of copper. But there's a little problem. That's if everything goes perfectly. Is everything going perfectly when I do this? No. What percent yield did I get on the last? So what percent did I get? So my percent yield was 48.8%, right? So I can actually only expect 48.8% of that. Makes sense? So I'm really only going to get 0.488 times 34.4 grams. Percentage of decimal times the mass. Because the way I'm doing it, I'm getting a little less than half of what I'm supposed to. See why I can only expect that much? Because when I did the lab the first time, I only got 48.8%. I can't expect it to suddenly be much better. Okay, so that's the math. There's only one more variation on it. Okay, but details. Percent yield tells us how efficient a reaction is, how well it went. The percent yield can't be bigger than 100%. You can't actually make more than you theoretically could make. If you get over 100% for your percent yield, what's in your dish is not what you think it is. It's got to be something else, because that's the only way it's going to weigh heavier than what it's supposed to be. Got something in your dish that isn't what you think it is, because it's now too heavy. It was all the right stuff. It at best would be the same weight as what you calculated. It's often less than 100% because of poor lab technique. If you miss stuff when you're pouring, I took a class, one of the classes you take is a chemistry is called quantitative analysis. Okay? And quantitative analysis means, can you analyze things to the right quantity? So for every 1/10% you were off from what you were supposed to get, you lost 10% on your lab. That you had to make sure you transferred everything that you were supposed to. And the reactions weren't 100% efficient, so you couldn't even tell for sure what you were supposed to get. The instructor knew how efficient the reaction was, but we didn't. So I just had to use the technique and try to get as much as possible without spilling any drops. I got my A. Okay. Some reactions just don't go to completion. That they start and then they make so much and they stop halfway. They repeat it to see if whether they made some silly mistake along the way. You know, because if you get the same percent yield 3 or 4 times, you're pretty confident that in your technique. Right? Bad lab technique, well, tends not to give you the same answer over and over again. You tend to spill different drops every time. Okay. Then there's side reactions. That means make things besides what you want. Use up your reactants before they make what you want, which would be, instead of making carbon dioxide, making carbon monoxide, or making carbon. If I make carbon and carbon monoxide, I don't have enough to make all the CO2 I'm supposed to. Okay? So I want this reaction, but, well, think about it. If I did this lab, it's okay because copper is going from copper 2 to 0. What if I did it the other way? Sometimes it could go to copper 1, sometimes it could go to copper 2. I'd get different amounts based on whether it went to copper 1 or copper 2, because I have a different balanced equation. That would be a different side reaction. Okay. Hey, but the one thing that doesn't affect your percent yield is your limiting reagent, because you base your theoretical yield based on all of your limiting reagent being used up. So you compare it to how much you should make when your limiting reagent is gone, not how much you should make when everything's gone. So you still use that smaller number for how much you're supposed to make. Student completely reacts 5 grams of magnesium with an excess of oxygen to produce magnesium oxide. I would show that to you, but it would blind you. Magnesium burns hot enough to give off ultraviolet rays that can damage your eyes. Okay, that's why I'm not going to show it to you. So I could do it and you'd watch the glow, but then I have to worry about the fact that everything I made was a carcinogen. And that it burns at about 3,000 degrees. Minor reasons why we're not doing that experiment here. It'll blind you. It'll burn you. It'll make a carcinogen. No, because it doesn't have enough mass. It's really hot. Okay, so I want the student's percent yield, so I know that at the end I'm going to do percent equals actual over theoretical times 100%. That's what I'm trying to fill in. So, do I have an actual yield? Yeah, it's in there, right? It's in there because they can't expect you to go burn it, so that they told you what a yield was, and the yield was the product weighs 8.10 grams. So I know that number. What about the theoretical yield? No, I got to do a problem, so I got to start off with the 5 grams of magnesium, change grams of magnesium to moles of magnesium. And 1 mole of magnesium is 24.31 grams. And then I want to get rid of moles of magnesium and change it into moles of what? We should probably write an equation, shouldn't we? I can't change it to moles of anything until I write an equation. Mg plus O2 makes Mg next to O. O is 2 minus, Mg is 2 plus, so it is MgO. I'm going to have to balance it by putting a 2 in front of MgO and a 2 in front of Mg. So my product now is MgO. They didn't tell me what it was before. And then I can turn moles of MgO into grams of MgO. 1 mole is 16 out of 24 is 40.31. So 5 divided by 24.31 times 40.31 equals 8.29 grams of MgO. So that's my theoretical yield. So 8.1 divided by 8.29 times 100% is 97.7% yield. That went much better. Here's another one. Yep. Okay. Does that make sense? Okay. That's all I got. So here's 3,000 of them. 10. Up here, I have a couple more. I don't want Jake to get away with it, not having to do it. Hey, there you go. Okay, so number 1 on here is using the same equation as the example. On the other ones, you probably have to write some reactions.